Good morning, everyone. I welcome our next speaker, Mr. Vipul Kocher. He'll be briefing us today on the topic of AI for software quality assurance. Mr. Vipul Kocher is a proud alumnus of MBM Engineering College, and he's also the co-founder of TestAING.com. Okay, I think there is some problem with Microsoft Teams. Give me just 1 minute to resolve.
Mr. Vipul Kocher is an ex-Adobe engineer and an IITian. He has 25 years experience in software development and testing industry. Besides being the creator of world's first AI testing certification AIU, Vipul sir is also the president of Indian Testing Board and convener of Stepin Farm and national convener of Indic Academy. He is a founder of Testing.com, that is world's first AI-focused testing service company. He has been a keynote speaker at many testing conferences worldwide. He has won several awards, including the Best Paper Award at Star East 2006 and Logica CMG Triple Star Award for the most original contribution at Eurostar 2005. Now I welcome Mr. Vipul Kocher sir. Sir, please share your view. Sir, आपका mic.
Thank
Sir,
you,
please.
Sangeeta ji. Namaskar all.
Namaskar,
I
sir.
will share my screen. Thanks for your kind introduction. I'll share my screen. I hope you can see it now. We are going to talk about testing of AI models and applications. The word QA is much larger word, quality assurance, of which testing forms one part, quality control, if you may. So my focus is not the entire large QA part, but more focused on testing part. And it is important to make that distinction so that there's no gap in the agenda of your understanding and my understanding. So what is it that we are going to talk about? We're going to talk about AI development and testing phases first. And then we are going to talk about what are various techniques that are available for AI testing and some levels of AI testing. And generally, understanding that you guys may or may not have exposure to the testing world, I would try to give some background information. And I would try to give you some examples, etc. I'll not do product demo, but I would try to give you some examples. So that's what I'm going to do. But before I go there, I'd like to tell you a little bit about myself, what I have done in the world of AI so that you understand where I'm coming from. A long time ago, I gave up doing hands-on coding and development. I moved from being a device driver, writer, and I was writing middleware and TCP/IP stacks, network programming, and so on. For mobile devices, smartphones, handheld devices, way back in 94, 95. From there, I moved into testing. And after many years, I joined Adobe, where I was managing Adobe Reader or Acrobat Reader. Then I left Adobe to start my own company, which was a testing services company called Pure Testing, and ran that for 8 years. Now, in those years, it became clear to me that from moving from a product to services perspective, it required a sort of mindset change. In product, you typically try to go very deep, whereas in services, you try to do what the customer asks you to do. And that distinction is important to understand when we start talking about testing of AI applications and so on. So that's one part. Second part is, I sold that company and moved out of testing world, involved only in doing trainings and research in new technologies and how to test those. So my exposure to AI from point of view of commercial interest happened in 2015-16 time frame. And that's where it started to become clear that AI is becoming prevalent. It's going to be a dominant force. And unfortunately, I didn't see a lot of testing happening there. Very little commercial stuff happening. Even in the academic world, a lot of research on testing of AI applications wasn't happening. Testing has always been a stepchild, so a lot of research anyway doesn't happen in testing to the same rigor as it happens in the computer science development world and so on. But at that point of time, when it became clear that not much is happening, so I thought that we would start creating methods. It was more like research, and we'll see how to test AI applications. We'll build a framework and theory around it, and make it available to the public in general. That was the result. The result of that was Artificial Intelligence United, an international certification to come out of India, and totally done in India by Indians, but accepted worldwide. So translated into Japanese, translated into Korean, translated into Spanish, being delivered in North, South America, Asia, Europe, and so on. So we were very enthused with the success of that. But that was just the beginning. And so ISTQB, which is a dominant force in software testing world, it stands for International Software Testing Qualifications Board. It has the de facto standard in testing certification. Even ISO now refers to ISTQB glossary and ISTQB terminology and syllabus and so on. So it is a worldwide body of which I represent India. ISTQB adopted AIU syllabus, and then we worked with other people to, now we are creating, it's in beta now, where we are creating an ISTQB syllabus for testing of AI application. So that sort of gives you an idea of how important testing community has started to look into AI and building frameworks around it so that AI testing, AI application testing can happen nicely. In the process, when I realized that there aren't many tools available, I created a company called Test AING, TAI, and TAI is the company that essentially just give me a second. So TAI is the company that basically creates a product now. Now, when I say TAI has created a product, am I going to talk about the product? Probably not. I'm going to talk about the needs, because we created a product because there was a need for testing, right? So I will talk about these three different things that we were looking at. Now, interesting thing is that most of you, would have exposure to AI. Many of you would be doing AI projects through yourself or your students or in the industry. And I don't code anymore. So I try to run this company called Test AING or Testing, which is focused on building an AI testing product. Again, one of the first out of India. Nobody globally has this kind of a product. Proudly looking at Make in India. So usually when I make a presentation, it is to a testing community. And there first I have to explain what is AI. And so my first half of the presentation usually is about explaining AI and the challenges of AI development. And then I move on to challenges of AI testing. Fortunately, I believe I'll not have to do this here. So I would rather start with looking at AI lifecycle and how typical projects happen in industry with respect to life cycle, and how do you need to test them, where all can you test them, what are the challenges, and so forth. And then we'll talk about the techniques and stuff. So there is there's no standard terminology of testing related to AI. Well, actually, AI is related terminology in the entire machine learning world is also not there. And some of my friends who have worked on the syllabus, they are also leading the ISO standards for testing in AI and so on. So we are building that terminology. Now, Google, for example, uses these two words, offline and online phases in machine learning. And I'm not going to talk about AI in general, but my focus is on machine learning because that is one of the most predominant things related to AI that we do today. So what is offline phase and what is online phase? When you train a model and validate it, test it, and then select one final model, that is your offline phase or training phase. And once you have your model, basically you deploy it with the rest of the system, and then basically you use it for inference. That prediction phase, basically we are calling it online phase. Now, why am I explaining that? Because there's a potential that you might confuse online and offline with not being connected to the internet and being connected. Here, we don't really mean that, but offline and online is with respect to usually, in this particular case, input data, live input data. Typically, you would not do model training on live input data. You would have a fixed set and you would try to use that. But when you go to deployment, at that point of time, you go online, you treat the live data. So that's how typically things happen, and hence offline and online. I don't think I really need to explain anything here, but if there are any questions, feel free to ask. Are there any questions so far? Why is this distinction between offline and online important? I will explain that in a short while. So how does really a machine learning project work? So there are many ways to depict it. One of the ways to depict it is using modified CRISP DM process. And we have not done it in loop, but the sorry, cannot hear you. Did somebody say something? Okay. So in which case I will continue. I can hear some sound from somebody. Okay. So first phase, data acquisition. So typically in a machine learning project, you would acquire data. And of course, this is one of the most crucial and one of the most difficult steps for many problems. Especially when you are dealing with supervised learning, then it becomes even more problematic because then you have to spend a lot of time in your data preparation, labeling, and so on. That's your step two. So step one and two, everybody knows forms a large part of your machine learning life cycle. A lot of budget gets spent here, a lot of time gets spent here, and it's not just one step process, which you will see later. There's a lot of iteration that happens between 1, 2, 3, and 4. And so then you do your hypothesis modeling, you choose your algorithms, you basically try to train your models, then you evaluate your models and try to interpret their outcomes and whether that's good enough or not. And while I've shown between 3 and 4 a lot of iteration, actually iterations can happen anywhere from 1 to 4. So for example, between 1 and 2, you could do a lot of back and forth. This is something that most people don't really realize or recognize unless they've done a few machine learning projects. And it becomes very difficult to then, because of the highly iterative nature, it becomes very difficult to put a framework around it. Once you have done your evaluation and you've arrived at a model, then you basically put it in deployment. And once you put it in deployment, then development, so the word development here is written wrongly, it's deployment. And then you go to operations. There also we are doing some testing. And we are also doing testing at stage 3 and 4. And most of the developers would say, what's the big deal? Well, the big deal is developers do their own testing, stage 3 and 4, and 5 and 6, sometimes developers and sometimes testers. And when testers do their testing, they have no idea whether there's any machine learning component or AI component in it, one or more, and they don't care, and they test it like any other system. That is basically the problem. Two problems. One, the first circle that you see encompassing 3 and 4, developers think there is no need for testers to do anything here. We have all our metrics, and that's good enough. And 4 and 5, the testers don't know what to do, so they think they don't need to test anything special. They just need to do testing as they are testing any other system. Now, whatever phase one is in, they think you don't need really anything special with respect to machine learning. And that's one of the biggest challenge. I've talked to a lot of CEOs, CXOs, heads of AI machine learning departments, and most of them come back to say, but why do you need testers when we are developing the model? And I say, why not? Oh, we have, testing is built into machine learning. And when I ask them to explain, they say, we have all those confusion metrics and all the other types of matrices that are there for different types of learning. We use them, and based on that, we evaluate the model. And the only thing that I have to tell them at that point of time is it yielding you the right result? Ultimately, when your model gets deployed, is it good enough? Could it be better? And if you look at the unit testing history, initially developers did all the testing. They thought there is no separate testing department required, no independent testing required. But what has happened now? While developers still do unit testing, but there's an increasing role testers play in reviewing the requirements, reviewing the design, and reviewing the unit test cases. Sometimes they actually do unit testing also, the testers. Or they review the test ideas and test cases that people are really looking at. So the whole division between development and testing is merging, and you need a tester's mindset. That is a very important lesson I want to drive here. So my prediction is that in coming time, we'll see a lot of research related to testing happening in 3 and 4, and also a lot of role change happening there. And 5 and 6 is where, based on AI systems characteristics or machine learning systems characteristics, testers need to upgrade their knowledge so that they can deploy the latest techniques. So let us see what all those techniques are and what we really need to do. So what are unique challenges of testing AI systems? One of the biggest challenge is non-deterministic nature of AI systems. Now, this is something which AI developers or machine learning engineers or data scientists typically understand. But management usually doesn't, and testers typically don't. Why is non-deterministic nature of AI systems a problem? So when I go and look at a picture of a cat or a dog and say 40% I think this is a cat and 60% I think it's a dog, and the picture is actually of a human being, you have a problem. A typical system, a deterministic system, will say this is a cat, this is a dog, and you would either accept it or reject it, and end of the story. So confusion metrics can be created even for deterministic systems But normally in testing world, we don't use confusion metrics because every single item that is not done properly is a bug, and you log the bug and so on, and you don't really care much about area under the curve and F1 scores and so on. You want 100% accuracy there. Non-deterministic systems, that something can be fuzzy, that something can be, a maybe can be an answer there. Testers don't understand it. Now that has two implications. One, I need to have an understanding of what will constitute a pass or a fail for my test case. Second thing is that good enough? For example, in pharmaceutical industry, if I went to them and decade ago, if I said I'm going to give you an answer of a 90% level, are you going to be okay with it? And they would have barked at it. They would have been very unhappy at it. They would have said, sorry, we are a regulated industry. We cannot do that. Now they've started to accept it, but still the bar is set very high there. And you need basically still some more confidence than just saying 90% or 60% or 80%. So that is one of the biggest challenges that people have. Somebody has probably unmuted themselves. So there's a lot of noise on the line. Thank you so much. Second thing is lack of test oracle. And so what is a test oracle? An oracle is a means or mechanism of giving you the future. So we have a lot of oracles in India. The city I come from, Bikaner, probably every fifth person is a hobbyist Jyotishi, either looking at the horoscope or looking at the palms or palmist, or some people even face reading and so on. Every fifth or sixth person. So we don't have lack of oracles, but oracle in the world of software testing means a system which can tell you what is the expected result, and based on that you compare the expected result with the actual result. If the two match, you say pass, otherwise you say fail. And this is one of the biggest challenges in one of the, in addition to non-deterministic nature, you also have this challenge of lack of test oracle. So you have no system which can tell you whether your what is your output going to be, because what are the techniques that can be used? What are the tools that can be used for testing? And that is another challenge. I've already discussed, the confusion in testers and developers about the role of testing and development and what all can be done. But once you have taken care of all of this, there is still a bigger question, especially for regulated industries. It continues to haunt those industries. How do we trust the result of AI? Now, if there's an accident and a human being rams a car into another car, we never go and ask this question: what is lacking in our procedure? How can we guarantee 100% that human beings do not do accidents? And we see so many accidents, right? There's so many of them that happen. But a car does one accident, kills one person, a driverless car, an autonomous vehicle, and that is not only news. You start debating whether AI has arrived or not, whether it is good enough or not, or whether AI will solve the problem or not, and so on. So clearly, we don't have similar expectations from human beings and our machines that we create. We want our machines to be held to more exacting standards. But when our machines become complex, then we ask them, how did you take the decision? And unfortunately, the machine cannot explain. And if the machine cannot explain, then we say, this is not good enough. We need explanations. And that is one of the area in which a lot of research is happening today, explainability. Right? So to establish trustworthiness of AI, you need three different things. You need transparency, you need interpretability, you need explainability, and of course, you need freedom from bias. So we'll take a look at some of these factors and see how you can test for those. But this is one of the challenges of AI testing. How do we know AI is doing things correctly? Because sometimes you can arrive at the right result, using a wrong method. Today, how does testing really happen? Data scientists, they do random testing. At best, what happens is that you hand over your model with attendant data pipelines and all the framework around it to testers even before it gets deployed, and then testers start throwing different types of input data at it. So it's random testing, and if random testing is good enough, we say that's good enough. Probably there is something lacking there. Okay. And last point, security. Security. Mr. Sankanan 999, if you would please mute yourself. Thank you. So, security, what is the challenge there? Well, the biggest challenge is, especially when neural nets become more and more popular, the whole adversarial attacks and how you can fool AI, that actually becomes a big challenge because it has huge implications. So let us look at, what's the difference in conventional versus AI-based system testing. So the diagram, crisp DM diagram, now is more from a point of view of blocks that I have presented. The first, the upper diagram was created by me, which talks about data pipeline, which goes into AI model. So I'll explain what's data pipeline. And then you have non-AI components which get integrated together. And when you AI and non-AI, when it comes together, it forms an integrated system which you test, and then it becomes a deployed system. Now, typically, when you have data coming into your model, either for training or for consumption and inference, the data generally cannot be used as is. And there's sometimes very complex pipelines to clean data, to reduce the data size, to pick up the data, to do or to fill the gaps in the data if there are any, weed out outliers or look for outliers, as the case may be, and so on. So there is a lot of effort that goes into cleaning up of the data and so on. So it is important that data pipelines also be tested very, very robustly. And what happens is what I've seen in so far, that when developers they do stuff, data pipelines are not tested very well. They are tested for best case scenarios or happy path scenarios. They are not tested for initial assumptions that you have about data. So mind you, please put a bookmark. This may become our first point of testing. Okay, and then it feeds the AI model, and finally you get there. So if you look at the lower diagram coming from Google's paper on testing, one of the good ones, in traditional system testing, you have different test levels. So a test level is a specific set of activities being done with specific objective. When your artifacts that you want to test, they are of a particular type. For example, unit testing is the typically one test level at which testing happens, where you test classes or methods and functions. So you test units. It's also known as component testing. And sometimes people differentiate between unit testing and component testing, where component testing is maybe composed of a lot of different units, but you don't have access to those units. So you treat it essentially as one unit. In hardware industry or in embedded systems or automotive, component testing and unit testing are treated separately, especially ASPICE treats them separately, where component testing is 2 or 3 different units along with some hardware maybe, which form one component which then gets integrated as components. So that is one or maybe 2 test levels we are talking about, unit testing and component testing, or unit and component testing being the same depending on which industry you're coming from. And finally, you start putting together the units. And with DevOps happening, Agile happening, old theories about integration testing like top-down, bottom-up, and doing big bang integration, those things usually do not happen. You start integrating things as soon as you can. There are a lot of tools available for mocking up the interfaces which have not yet been coded, test doubles, and so on. So you basically get your drivers and stubs This is called as component integration testing. And then you go to system testing, where system testing is when you have integrated everything, and then you do system testing, where entire system is tested in an environment which is as close to production environment as possible, and then finally you go for deployment. And as systems become more complex, there's one more level that has come in, for example, system integration testing, where you try to integrate multiple systems. All these multiple systems, they work independently, they are independent systems, but together they give you the functionality. For example, when you go to any e-commerce website, you might actually be dealing with a large number of systems, for example, a payment gateway system, maybe some other reconciliation system, GST system, and of course the e-commerce system proper itself. So there are a lot of different systems that come together. So these are different levels: unit testing, integration testing, system integration testing. And of course, you may have acceptance testing also somewhere in between, either after system integration testing or after system testing. Unit testing, beta testing, alpha testing, beta testing are also a type of acceptance test. So I hope I have given you an idea of different types of tests that happen in industry. This is mostly for software, but if you are dealing with embedded systems and hardware software, then there is a separate pipeline that runs in parallel, which is hardware unit testing, hardware integration testing, and then at some point of time, hardware and software, they get integrated. So integrated hardware software testing, then they form a system. So that system testing is where the entire system gets built. For example, in car manufacturing. And then you get system acceptance testing. So it doesn't matter. You have understood what are these different test levels that we are talking about. Do you have any questions so far with respect to test levels? Different people follow different models. I don't have a diagram right now for model, but waterfall, for example, is what people used to follow. They found that it doesn't have enough testing, so people started following what is called as V model, where you have, yes, Mr. Shailesh, please go ahead. You have a question? I can't hear you. I have your hand raised. Hello. All right, I'll move on then. Yeah. Okay, so we'll come to that part, which is better. Um, Let me explain first V model and Agile a little bit to you, how they work in industry, and then I'll answer this question in a moment. Is that okay? All right, thank you. Thank you. So V model, what happens is people found out that you need to do testing not at the end. In waterfall, you were doing um, requirements, then you were doing design, then you were doing development, and then you were doing testing. It is like performing a postmortem. The patient is already dead, right? And then you perform the postmortem. Now you are finding defects. Can't I find defects early enough? This is like, after your child has appeared for the exam, and then he or she comes home from the exam, and then you as a parent look at the question paper and say, oh, why did you study it like this? Well, the time of, giving that comment has already passed. This is what the feeling people had with respect to waterfall. So they started doing V model, where every development activity started having a testing activity. For example, with respect to requirements, you would start writing test cases, acceptance test cases. If you're in design, then you'd start writing integration test cases. The very fact of writing test cases reveals a lot of shortcomings of the design, of the requirements, and so on. Developers and people who have written those requirements and design, they have a mindset. They have put their assumptions in the artifact that they've created. However, when a tester comes in or somebody thinks purely from a test perspective, they ask a question, okay, but what happens in this case? And what happens in that case? And at that point of time, people start to see the holes in their requirements, or incompleteness in the requirements, incompleteness in the design. So test cases should not be written towards the end, but they should be written as early as possible. And then you have static testing, which has become very popular now again because of DevOps. So reviews, use of tools for doing static analysis like checking coding guidelines, checking coding construct, checking code for security issues, and so on can be done automatically using static analysis tools. So then when you come to unit testing, there are a lot of unit testing frameworks that are used today. Um, there are a lot of methods and techniques also available. People do what is called as test-driven development and so on. So all of these things really do not matter. You also have white box testing, which is like statement coverage, branch coverage. It is important for us to understand these types of tests. Unit tests, both white box and black box, meaning when you are doing code coverage, statement, branch, MCDC, those kind of coverages. And also when you are checking the functionality using JUnit or CPP unit kind of framework, unit testing frameworks where you are just giving input and observing the output. Because we will need analogs for these when you are doing AI testing. Okay, so I'll just put a bookmark here. We'll come back to that later. The good thing about unit testing is because you are using code to test code, it can be automated very easily. Then you come to integration testing, and there also you have already written the integration test cases, and there are tools available for doing API testing and so on, and that also can be automated. So here, manual testing and automation testing do not have any distinction between the two, because first you write code, run it once yourself, and after that, because it is code, you make it part of an automated suite and it runs automatically. You don't have to do anything special. Then comes the part of system testing, and you start dealing with user interface. And user interface is human clickable. It has to be useful to human beings. It should be usable, easy to use. There should be no overlap of UI elements, and so on and so forth. So when you start doing user interface testing manually, at that point of time, you ask yourself a question: can I do in an automated way? Yes, Ms. Soumya, please ask your question. I'm guessing, yeah, go ahead, Abhishek. Yes, Mr. Narpat, you have raised your
Sir,
hand.
I'm able to unmute.
Yes, please go ahead, Soumya.
Sir, I just want to ask that. Yes, sir, I just want to ask that regarding the various testing techniques which you are telling, white box, inbox as well. I just want to know that whether all these testing techniques are required to, go for a certification test like ISTQB or something. We require knowledge of all these categories of testing for such kind of certifications.
Yes, you do. Because although white box is less in especially ISTQB foundation level, you do less white box because most of the testers are doing black box testing. So, but you still need to have that knowledge of white box testing to some extent.
Okay. Okay, sir.
Anybody else has a question here? Pleasure. So coming back to the testing that we're doing now, should it be manual? Should it be automated? And automated, the problem is that now you need a mechanism in your tool. It's not just a function call. Now you have to locate an element. Oh, this is a button which I need to press. This is a text box in which I need to enter some text. And UI is one of the most volatile components of an entire product. It keeps changing. So if I write my tests using some tool for automating UI testing, the biggest problem is in the next release, maybe 5%, maybe 50% of my tests would need to change. That becomes a big problem. Okay. So what to do? So people have what is called as a pyramid, which I'll show you shortly, and you basically try to do testing accordingly. Please understand, there's no competition between manual testing and automated testing. First time you have to test manually when you are looking at the system, because whether that is working correctly or not, How will a human being perceive the system? That is manual testing. But once you have done it, and if it is an important test that you would want to do again and again and again, so that there are no problems which are called as regression problems, for that you will need to automate it. So still you try to see what is the intent of my automation. Is it a particular API that I want to exercise on the back end of the server? If yes, then API testing may be good enough. But if you want to do an end-to-end flow, then you may need to automate using GUI. Okay, I hope that helps answer that question. If there's anything else, you can unmute and ask me. So now if you look at model-based, machine learning-based system, you look at what is happening. There is this additional part of model training, which we are calling as offline. So first of all, that needs to be taken care. Second thing is that you need to take care of integration in the live system. But AI or machine learning is very different from programming. In machine learning, you are hardly doing, especially with respect to the model, you are hardly doing any coding. One line code that you need to write, which says model.fit, and your model gets trained. Model.predict, and you get your prediction, right? To save the model, to load the model, just one line each. It is the data which is the most important thing. Earlier, people would write a lot of code, then they will have some data, and they would use the data to test the code. Today, the data generates the code, in a sense. So if you are not, so what is it that can be tested and should be tested first? Your data, because that is what is going to basically create all the things. So if I give you an analogy, so garbage in, garbage out. So if you provide incorrect data, then it's going to provide incorrect results to you and so on. So that is basically one of the challenges. So if you look at the upper part of this now, you need to do ML infrastructure tests, you need to do model tests, you need to do data tests, you need to do bias tests, you need to do monitoring of the data test. So a lot of data related testing needs to happen. But it is good to write it this way, but it becomes difficult. What are the tools that are available? What are the things that I can do? So we'll talk about that in the second part. Now, what I'm going to show you is something called a test pyramid. The original pyramid was the top pyramid of this diagram. Okay, so first let us discuss the top pyramid. Integration test, end-to-end test, exploratory tests. Okay, now what are the tools that are used? And below integration, there would have been one more layer called unit tests. Unit test would be the large. So why is it shaped like a pyramid? Why not a square? Why not a circle? That is because pyramid has a wide base. The base is, the widest point in the entire pyramid. It's actually a triangle, if you ask me. It's not really a pyramid, but test pyramid versus test triangle. Test pyramid sounds more interesting, more mystical. So if you look at integration test or unit test, so you say I should have a large number of unit tests. That means every person who is developing their code should write a lot of positive and negative unit test cases. They are most easy to write. They are cheap. They can be run very cheaply, and they have the potential to detect maximum number of problems, which later on you may not be in a position to detect, because once something is buried in a piece of code, you may not arrive at right data and right conditions to trigger that particular point in the code. You don't even know that such a thing is happening. So it is here that you can actually examine the entire code in its entirety to the last detail possible. Then comes the integration test, where you use API testing tools like Postman, SOAP UI, and a lot of other things. With the advent of DevOps and with the advent of microservices, these tools have become again very popular and very pervasive. So integration test. Then comes the part of saying end-to-end test, which are done manually. So these number of these tests should be low or less as compared to integration and unit tests. These can also be done after it has been done manually. They can also be done in an automated way. And what do we mean by that? So using tools like Selenium, which is one of the most popular tools. Or now a lot of other tools have become popular, like Mocha, um, Espresso, and every day you have new tool coming up and so on. So what we are saying is that the number of these tests should be less. And then comes exploratory tests, which are totally done manually. They cannot be automated. And so those are tests that should be relatively lesser in number. Now this is received wisdom. I don't agree with this diagram. Martin Fowler has created this diagram. You can find this picture on his website, martinfowler.com, or something like that. I don't agree with number of exploratory tests, but since this is not about testing discussion, this is about AI, so we'll just leave it at that. One thing that has become very popular, not very popular right now, but is likely to become very popular, is AI triggered or AI enabled test bots. So there are a set of companies which are delivering tools and services for bot-based testing. So what you do is you use reinforcement learning, especially Q-learning, and you train your model using a lot of different applications. And these bots, they basically learn how to navigate the application. So after learning, they understand they can go to every part of of your application. They can traverse any path. So end-to-end tests can be executed. And because this is being done by a bot, and they learn what is right and what is wrong path, especially given the reinforcement learning that you are doing, right? So what happens in this case is that these bots can test automatically on their own, and they can keep doing these testing, uncovering new paths that even a human being may not have uncovered, and so on. I believe this is going to be in next 10 years. This is going to be the future of software testing, a lot of bot-based testing. A guy named Jason Arbon runs a test.ai, and I believe that's the website. And he's ex-Googler, he provides services around this and maybe some product as well. There are other things also, but we'll talk about that later. Right now, coming back to test pyramid. So this was the original test pyramid. But then people said, okay, now there's AI. So how can this test pyramid be modified? So if you look at it, there are three different pyramids that you see. Blue one is your typical non-AI conventional programming pyramid, unit testing, service testing, UI testing, but this is related to some of the non-AI components that we are talking about. This is not still the full entire system. That's why you see some UI tests here. Then there are transformation and ML pipeline related unit tests. So essentially what we are talking about is the whole data that comes in and gets transformed. You basically do unit tests there. And if there are multiple ML models that are working on the data, because that's also a possibility. So basically you test those. That is your ML pipeline. That is the integration that is happening. And then there are unit tests related to data validation, data features, and so on. So basically you look at each individual item in the pipeline, and that is the kind of testing that you do. But this is not a good picture or a complete picture. There is the middle layer also, where once the model has been created, you basically, both ML and data pipeline, you look at them, and you look at your model performance, model bias test, model fairness test. But in my opinion, the fairness test and bias test should happen first on the data, then they should happen on the model. And then there are contract related tests that can happen there. So this is one way to look at it, but I will show you a much better picture of what all different tests can happen and where. I wouldn't say a much better picture, but a different way to look at that picture. Any questions so far on the pyramid? If you have any questions, feel free to ask. Because now we are going to pretty soon jump from theoretical stuff to how things actually get done, and challenges that we faced in our company when building testing services and building testing products and so on. Okay. Now let us take a look at what can we do which is going to be different. Okay. Meaning, where are new things which are happening? Well, first, one technique which is found to be very useful in AI testing is called as metamorphic testing. And I'll explain metamorphic testing in a short while from now. Another thing that people started looking at is, how do I do white box testing of AI models? Well, you all know that there are different types of models. For example, there are tree-based models, there are neural net models, and there are all these different types of models that are there. All models, neural nets are probably the hardest to understand what is happening. And so people started looking into missing coverage there. And this is equivalent to your code coverage that you're talking about. Can we have a neural coverage also there? So this is white box equivalent for neural networks for unit testing. Then there's a lot of research in bias and ethics that are happening, and some tools are also coming up. Companies like Google, etc., they are releasing some tools. Some interesting things have happened with respect to ethics. For example, IBM announced that it will not work on face recognition anymore. Why? Because this technique, advancement in these techniques can be used by despotic regimes world over to identify people who are demonstrating in a protest, for example, and a legal protest, and crack down on them, or privacy concerns are there, and so on. So IBM, took a decision not to do it. Of course, other companies continue to do it. So it's a very interesting thing. And how do you basically, now somebody has to look into these aspects also. So testers now not only need to be testers, and they also need to be developers, because Agile and DevOps say testers, developers should play each other's role. But they also now need to be philosophers looking into ethics. So the responsibility of AI developers and testers is ever increasing. Then data generation. A lot of research is happening in data generation. I'm sure recently it became news where old photographs were brought to life. They could smile, they would turn their face and so on, right? And you could take your black and white photographs and color them and so on. So basically a lot of research in data generation through this GANs is happening. And our product also uses GANs to generate data. Not foolproof yet, but this is area in which a lot of work is happening and will aid testing a lot. And then this whole auto ML thing, that's a big thing, because people. So Abhishek ji asked this question about manual and automated testing, and what I find interesting is, forget about automated testing. Here we are talking about automated model creation and automated model validation and so on. So all of these things are already happening. So that's the interesting part. Let us move forward and let's look at a few more things. So what happens in metamorphic testing? While I'm going to do 1 or 2 slides explicitly on metamorphic testing, but here at a high level, I'd like to say there are 2 ways to do metamorphic testing. One is augmented data. So you have data, you transform the data, augment it, and use it to do metamorphic testing. Other is that you basically look at input and output and identify metamorphic relations to test it. What are MRs? We will discuss it in a short while from now. Neuron coverage helps you do adversarial attack testing. So neuron coverage is not only just a white box testing technique, but it is also very helpful in uncovering potential attacks, attack vectors, and also using those and using neural net, you can actually do corner case detection and make your tests more robust. Explainability, I told you, is a big thing. While I'm not going to talk a lot about it, because chances are most of you know explainability stuff, but if you would want me to talk at the end of it, I can talk a little more on this. So some of the algorithms and techniques that I used for explainability are LIME, GradCam, Shapley values, what-if scenarios. There are over 24 such things available, and more are coming up every year. Then there are some tests using a linguistic analysis-based technique, in which my company is doing research. This is a method I had developed. It's very interesting. Metamorphic testing developed around turn of the century, around 2000, and this technique, linguistic analysis-based method, was also developed at the same time. And both techniques were developed for testing normal systems, but we realized that in addition to normal systems, actually AI systems can be tested very well using these two techniques. Combinatorial testing becomes very important in AI testing, which you'll see soon when your data and the combinations of data, they explode, and we'll see how it can be used. Okay. So we discussed about techniques. Now let's talk about test levels. What are different test levels that can be there? First of all, code review. So that's a sort of test level that I'm talking about, which doesn't exist, but part of static analysis. But at component level, there's a new level for model level testing and neuron coverage. Then when you create your model and ship out the model, I'm sure many of you would have used pre-trained models, but sometimes you don't know what how good that model is and so on. So basically what you need is an SDK testing there, API testing, sample app testing, documentation testing for the model that you are giving out. So there are standards that are emerging about documentation of models and so on, so that when you transfer model, when you exchange models, when you send model to somebody, or when you sell a model, then people understand details about your models. Okay. Then there is system testing and system integration testing, which are normal models that will happen. Now, please take a look at this slide first while I drink some water, and I will explain this in a moment. Typically, when you create, when you do your testing and you create a project plan, you also create a test plan. So, what is a test plan? Mr. Akshay, please mute yourself. Thank you. So, what is a test plan? A test plan talks about what all levels of testing you are going to do. Within those levels, what all different techniques you are going to be using for testing, and how much coverage would you do, and whether you're going to do automated testing or manual testing or a combination and so on. So all of these things you try to put in a test plan. And when I talk to testers who are working for AI companies, and since nobody knew how to test AI applications, I asked them, what's your test plan looking like? And their test plan looked like exactly like it used to look on non-AI applications. So I created this template which I can give to people. So what you do here is code review and static analysis, typically done by developers. And this is for your data pipelines as well as for your model. So when people do model tuning, they have a lot of things going for them, like hyperparameter tuning and so on. I'm leaving that out because that is almost outside the scope of testers. But then comes data related activities where you can check for data quality, check for bias, check for need for data augmentation. So there, developers or testers, or in combination, they could provide this kind of service. Then when you come to component testing, model testing is something that is the most important new thing, and where I recommend testers to do this activity, because developers do their own activity based on metrics, performance metrics, and after that, basically, they hand it over to the testers, where testers now use their own test data and so on and try to uncover problems. So that's model testing. Then neuron coverage, and then unit testing for non-AI components, typically done by developers. After that, there's integration testing, where people do data pipeline testing, and data pipeline testing again can be done by developers, testers, or in combination. Especially if you are very keen on doing data pipeline testing, try to provide easily callable interfaces to your developers, so that you can easily provide this kind of interface where testers can also use it. Okay. Then there is SDK testing, which is model testing for documentation, API, sample app that I talked about, where dev tester collaboration is required. And finally, you come to system testing, where you need to do your model testing again, and there are metamorphic testing techniques that can be used, but those are techniques, right? Right now, we are talking about types of tests, functional tests, non-functional tests, robustness, performance, scalability, because your model hasn't been tested for those, and for the first time, it will be tested for those things. You can actually do in model testing also do these kind of tests, but you'll need to do on the scalable system. These days, models are put as part of a container, for example, Docker, and deployed on AWS. which scales. Large number of containers are spawned when there is more pressure or more load and so on. So those kind of tests we are talking about here. At the same time, dynamic analysis testing can also be done. And finally, just I'd like to say system integration testing includes testing in the inference phase where you are making inferences. What is model testing? Metrics-based test or performance metrics, which confusion metrics, for example, or R square or RMS, RSME, RMSE, and so on. So you can look at those scores. You can look at for unsupervised, you are looking at clustering tightness scores, and you can also look at uh, things like lift and support and confidence for the association. So I'm not going. Yes, you have a question, somebody? No question. Okay. So then, metrics-based test typically done. There's somebody here who needs to mute. I'm unable to identify the person who is unmuted. Miss Premlata, thank you so much. Thank you so much. Thank you so much. So, when you look at model testing, metrics-based testing, developers always do it and they think this is the only testing that can be done. So those of you who either want to do research in AI testing, and we have collaboration, for example, with BITS Hyderabad, and we are looking at collaborating with a few other universities, feel free to reach out. We'll be happy to collaborate with you with research projects and so on, which are part of work that we're doing. So a lot of these different, or if you're in the industry, and you want to convince, then tell your developers that other than performance metrics, here are LA-based test cases and corner case testing, combinatorial tests, end-to-end tests, back-to-back tests, AV tests, metamorphic testing, explainability tests, model performance tests. So many different types of tests can be done at the level of model. So it's 12:04. I have approximately an hour more. If you want, I can take a 5 minutes break here, and you can come back. That will hopefully give you time to look at anything which is critical. So this is 12:05 by my watch, almost. So 12:10 we will start again. I am, you can get yourself tea, coffee, whatever you want. All right. I'll mute myself till then. Let us begin. Assuming everybody is back and you can see my slides. So let us go and start looking at, yeah, perfect. Let us start looking at all of these things one by one. First of all, data augmentation. Now, I'll give you an example. For example, one of our customer, um, one of our customers has a vision system AI pipeline where the camera is focused on a conveyor belt and they are picking up things and then deciding whether it needs to be sent to tracking or it needs to be sent for reinspection or whatever. And the thing is that it's not an implementation for one company. It is a product that they are selling. And the cameras and their qualities and lighting conditions change all the time in the factory. So when I input my data, my images could vary depending on the camera model chosen, the lighting, and so on. And I have only a few set of images, and I didn't even think about it whether they are coming from a particular camera or they have certain amount of brightness or contrast or what was the lighting and so on, right? So you basically need to look at those things. You might also realize that all the videos that you had or all the images that you had the object put at the center of the conveyor belt. But what if the object was only partially visible and there's no data? So basically, data augmentation requires you to look into, do a visual inspection, if possible, of the data that you have and try to find out what kind of things it is missing and augmenting. Sometimes just software-based tools can be used. For example, if you have a Python toolkit, you can any toolkit, it doesn't matter. But for example, you could change the contrast. You could change the brightness levels of the image. You could make it from color to grayscale and so on, right? You could downsample it. You could reduce the size. You could do so many different things. Um, you could rotate the same image. And we found some interesting thing for another customer of ours, which was doing object detection, that when you rotated the same image, didn't do anything, just rotated the same image by 90 degrees, for example, the accuracy went down like anything. So now that means that, the rotated images should be part of my training data so that it can basically train well and so on. So this is basically we mean data augmentation. It's an exhaustive big space, and that's basically difficult. Now, what you try to do in this case is, and this is something that has come from our experience. So you may not find this thing anywhere in the articles or anywhere, which is whenever you do image transformation by rotating or skewing or doing something else, then the developers are likely to come back and say, but in real world, that doesn't happen. In real world, nobody is going to give me a rotated image or a skewed image or a partial image. And then we have to basically find out real world cases or scenarios in which this can happen and go and capture those images and then basically try testing with those. And chances are you will find that your system fails. Yes, Manasa? Please ask your question. You are muted. Please unmute yourself. Hello. Can't hear you. So then I'll. Oh, from. Oh, all right. Thank you. So this is something that we found out, and of course, in some cases, you could not really find those images. For example, if let's say you have an image of a phone, you cannot have a skewed phone image which is stretched like this, right? So then developers are very right in saying How are we bothered about it? Why? So what if the accuracy is low? But something interesting happens there. What interesting happens is that when you include these images and do recognition after that, the overall accuracy of the entire system increases. So sometimes it is not about bug and solving a problem. It is about that even if it is not a real life image, but it helps you do better accuracy for your models. Why not? And that is another argument sometimes that you have to explain to people. Okay? Then comes the part of bias testing, which can be done at 2 or 3 different levels. First, just at the data level. Second, at the model level, once you have created the model. Third, at the final system level on live data, if you can. So what is bias? A pretty standard term that most ML people would know, but I would still like to arrive at consensus. Prejudice in favor of or against something. Now, both words are important, in favor or against, right? As compared to other, generally considered in an unfair way. So basically, sometimes you try to use another word called fairness. So you say, our system should be fair. There's a bias inbuilt into the word fair, right? Fair means lighter color. So our system should be fair. That means the word fair itself is biased against dark colored people or dark colored things. So that's an interesting aspect. But otherwise, when you talk of, let us say, affirmative action, reservation in our case, for example, is it not a bias? For sure, it is a bias, right? You are, or look at another bias. Average salary of same work being done by women versus men for the same role, same job, women get paid less, generally speaking, than men. That's an example of a bias. Now, this is a bias you would want to remove, whereas taking affirmative action is something that you would want to continue. So what does that really mean? That there you are calling the word fairness. So when it is a positive bias, when you want it, you typically try to think from a fairness perspective. Otherwise, you try to think from perspective of negative bias, which needs to be weeded. I don't want to discuss the positives and negatives of any of these systems. I am just telling you how it is, right? And let's take a look at why bias is important. So there was this lady who did this research, and I'm sure a lot of you would have heard this example, but just in case you've not, her face was not recognized by the face recognition system. So she went around checking publicly available face recognition systems, and her her research and asking questions, looking at the data. So, for example, where do you get face recognition data? So there is a open sourced data set which is available, right? And she went and asked people also, proprietary data set people. She found out that in training, 99 white males, they were being recognized with 99% accuracy. So she looked into the data and she found out that around 80%, right, 75% data was male faces. That means female faces were only 25%. If you take roughly 50-50 division in the world of males and females, you are clearly biased for males against females. Second thing, over 80% were white within that set, white faces. So we are naturally geared towards or biased towards white faces. So who would suffer? Well, if you are not in that male data set, so if you are non-male, females, so then you are going to suffer. If you are white, you are okay. But if you are any other color, yellow, black, brown, you are likely to suffer. So she combined both the attributes and she found out that black women faces were recognized only to the tune of 66 to 80%. Now, there's a very clear example of a bias that could be caught right at the testing, right at the data phase. You don't even need to create a model to find this bias, right? There are many such examples that are available. I'm not going to go there. And this is where you need to start doing bias testing. So, for example, I believe Google has a fairness kit or some tests available, and we have also in our tool. You can provide the data; it gives you data distribution, which helps you understand the bias. And we also use fairness toolkit, a different one, and we also have our own proprietary methods for looking at these. So this is the first set of tests that we do. Then when you test for model fairness, test for for classification. So you need to test for models robustness also. So for various different data sets, you need to look at prediction and how accurate you are. So at times, what you need to do is look at these classes and distribution of class, and confusion metric per class may also need to be done if there are multiple classes and so on, to understand how good you are with against each other, which class is better recognized, which class is less better recognized, and so on. And you need contribution of each class to overall confidence, overall accuracy. So this is another way to look at the tests. So that would give you better coverage of the model, and you can test it for other things. So we'll look at this part a little later. Then comes the part of neuron coverage. So typically what happens is that, there are, for example, there's a tool called Deep Explore for exploring or for looking at neural networks coverage. It's, a lot of papers in the industry which talk of neural coverage, talk of Deep Explore, and there are a few other tools available. And they have some sample neural nets also available on which you can apply. And then you see that, what all neurons get triggered, not triggered. And on that basis, you have a lot of different types of coverages. But the interesting part is that there's no universal tool available which can take in any neural net and then, just provide you coverage with it. Depending on the neural net architecture, you need to basically do some tweaking and so on. That is where we are facing one of the big challenges, that, for example, for CNN, relatively simple CNNs, it works very well. But for RCNN, there are difficulties. For RNN, there are difficulties, and so on. So neuron coverage is a equivalent to statement coverage: covered, not covered. And ideally, you want all neurons covered. But interestingly, sometimes you can use it for trimming of your models also. Whatever neurons never get covered but give you all the functionality, you may trim it to reduce the size of your neural net and so on. Then there is mutation testing. Now, what is mutation testing? You do random changes to your program and then test. And if your tests find bugs, that means you have a good test coverage. So typically in mutation testing, what you do is you take the same model, for example, vary the hyperparameters. So for example, I may vary the number of epochs, I may vary the number of layers, or I may vary just the random seed. And after that, I have two different mutations or many mutations, and I basically do comparison against each other to see which model gives me a better result and so on. So that is something that you can do. Then there's combinatorial testing. So what is combinatorial testing? When you have large number of variations, you can do a lot of combinations of those. And at the highest level, for example, I'll give you an example. This is like, your typical truth table goes on increasing exponentially. So what happens is, let us say you have 5 different browsers, okay? And each browser has maybe 3 to 4 different versions. So you have 20 browsers we tested, right? And these browsers are on different versions of operating systems. So, for example, Windows 7, 10, and within that, a lot of it. Let's say there are 10 such variations that are available. And then, there are different settings related to whether you have a GPU or CPU. So let us say 2 such variations or 4 such variations are possible. If I want to do exhaustive testing, I have to do 10 into I said 4 variations, so 10 into 4 into 2. So we are talking of 80 different environments in which I have to run. And if I have 1,000 test cases to be run, 80 into 1,000 easily becomes 80,000. So clearly you can see combinations, full combinations will not work. So people go for all pairs testing or all triples, orthogonal arrays, and so on. So that is basically combinatorial testing. And there are a lot of tools that are available for generating pairwise combinations. You can use AI testing for combinatorial testing for both AI as well as non-AI. Okay. Then there are function tests. I'll talk about the vision pipeline and linguistic analysis based in a short while from now. And then there is metamorphic testing. So let us talk about metamorphic testing. So metamorphic testing is used when you do not have test oracle available. Because you do not have test oracle, so what does it really mean? It means that since you do not have a source which will tell you whether this is a pass, what is the expected outcome, whether the test is pass or fail, so you have a serious problem. So you don't know when you provided some input whether the output is correct or not. But sometimes you don't know whether the output is correct or not, but you know the relationship between input and output, or you can derive a relationship between input and output. For example, let us say you go by a bus from point A to point B. It takes you 1 hour. It takes you 10 rupees. Now you go with your friend and your model is, let's say, forget about model. Now, there is this pricing that needs to be looked into. So whether, your model gave you 10 or 15 and whether that is correct or not, you don't know. So maybe model gave 15, maybe model gave 10. You say, I don't care. But instead of one person, if two persons go, I and my friend, it will be double the quantity of the previous case. So what is the relationship between input and output in this case? That if you double the input, your output is going to double. Correct? That is a metamorphic relation that you have derived. Or you may say more or less it will double. Assume if you buy 2 tickets or 4 tickets, then you get 1 ticket free, right? So there's a discount. So you can set some limits and say plus minus 25%. And if the answer is within that, then I would say this is more accurate, or 5% or 10%, whatever. So this is an example of metamorphic relation. Another metamorphic relation. What is the time taken to go from point A to B when one person goes X? When I don't know whether X is right or wrong, but if 2 persons go or 10 persons go, the time still remains the same. So the relationship is that there is no output variation. We change in just the number of input variations. Of course, if the input starting ending points change, then the timing will also change, and so on. So you try to find, these are very domain specific. And so there are a lot of different types of metamorphic relations, domain specific, model specific, and so on. There are 3 different levels of, and data specific. So you try to basically give data in different order and then see that whether you get a model with similar accuracy or not. That's also metamorphic testing. So there are a lot of different ways in which you can derive metamorphic relations. And once you do that, then you can do this testing also. So there aren't too many metamorphic testing tools available. You can use an Excel to generate once you have metamorphic relation or do a bit of programming, or you can even use another model to generate your metamorphic relation, and that will probably help you gain some test cases and so on. Okay. So metamorphic testing has become very popular. In the levels, system integration testing is where you go do inference testing, where you look at the model size, the accuracy, robustness, performance. And why am I talking about model size? There's a reason for that. For example, I have 2 versions of a given model. Not my model, my customer's model. What they do is they, it's an education company. On the phone, you can actually point to an object or point to a textbook or any book, and it tries to look at the text. First of all, it will do text recognition using neural networks, and after that, Once it has the text and the context, it will try to tell you what videos you can watch and so on and so forth. Now, that's a very interesting thing that is happening there. But you see, when I'm on the mobile, I have only limited amount of memory and limited amount of processing power. Most likely, my mobiles will not have GPU today. I'm sure 2 years down the line, all mobiles would come with chipset which will have a GPU as well as CPU or a combination thereof, whatever they will be called as. So when I want quick and dirty results and I'm offline, meaning my phone is not connected to internet, I use a local model. And when I'm connected, then I go and do on the cloud. So I get better and more accurate results. But the interesting thing here is that the same model, which is maybe 250 megabytes or 1 gigabyte in size and takes X amount of CPU power or GPU power, that will not work on my mobile. So I need to downsample my or downsize my model. So I may do quantization, I may do a lot of other things to do basically downsizing the model. Now I have to compare these two models and I have to do performance testing on both. And the accuracy cannot be too widely varying between these two, otherwise people will not like. So all of those tests are about model size, accuracy, and so on. Functional and non-functional tests that you do are typical. Any person will do these kind of tests. Now I bring you to our contribution to this whole thing. What is our contribution here? This is the whole pipeline rendered in a different way. So in a machine learning project, how much time do I have? 30 minutes. Good. How do things really work? So you can divide the screen into two portions. The upper portion is all about model training. Data comes in, then there are a lot of different transformations that happen to data, scrubbing of the data that happens. And then data goes for training, validation, and you do your model training, and now you can see those iterations. From the data pipeline also, I can come back. First thing that I would need is get data, so I do data augmentation. So number one that you see, data augmentation. Then I would do data fairness and bias test. That's basically your number two. And then you have data pipeline, so you do your unit and integration testing. You can iterate here. You're not happy with your data, you think it is not useful, you can't do anything with the model with this, you would do this again and again. But then you go to model and you find that your training is not good enough, it's not accurate enough. So then you go back, maybe augment your data, maybe get more data, maybe tweak your pipeline and so on. So again, and the model training happens. And then, there is this test data set that you have separately taken out. Once you have a model, then you take, maybe you've chosen 5 or 6 different models. You apply your test data set on all of them and then try to choose one model and increase its accuracy. So again, you go back, you can see the iterative portion here. On the selected models, you apply model testing and the iterations happen. And finally, at the end of it, your model testing is done, you arrive at a model. You choose one model and then you say, okay, now it will get integrated with the rest of the system. Or like the example I gave you about mobile, you could actually do a repurpose of, you could do a model compression. And when you do the model compression, your model characteristics may change. In which case you have to do model testing once again, but maybe to a lesser extent. Or you could just use the final model directly and deploy it. So repurposed model testing again include data pipeline, model training, model selection, some part of it, but to a lesser extent. Now you have a similar data pipeline coming with live data coming in, right? And then you integrate your model with it. So the model now consumes after the data passes through its things, and there are more components now, and the data finally then reaches your finalized model, which is this 9LA, integration of AI model and non-AI. Here you do on the pipeline, again you do unit and integration testing, and then you do some sort of, so first of all, unit and integration testing for non-AI components. Then when you integrate, you do again integration testing and system testing. Okay, and then you go to your system and you do your system acceptance test or user acceptance test and system integration testing, and LA linguistic analysis based tests are performed again, and then you make your system live, and things don't end there. Even on live, you basically keep testing. And what you do in live is that, all the prediction that you're making, you are comparing it, and now you have data also. So you check whether whatever your output is being produced, is it accurate enough or not? Because sometimes, despite everything, you might find out it is not accurate enough, or you may find that it is accurate enough, but people don't like it for whatever reasons, because maybe it is slow, maybe it doesn't integrate well, and so on. So there you have live data with data pipeline. So you do again model testing and live testing. So on the right hand side top end, you can see model testing includes metamorphic testing, coverage testing, explainability testing, testing for adversarial robustness, and testing for performance. Whereas live tests includes inference test, A/B tests, more performance tests, monitoring tests, and testing for concept drift. What is concept drift? Your model becomes, like your car, starts giving lesser and lesser average as time goes by. Similarly, your model may also become less accurate and less accurate because underlying truth has changed, reality has changed, people's tastes have changed. For example, same fashion prediction that you were doing earlier may not work, and so on. So things may change. For example, COVID happened, and whatever people are watching on Netflix, the type of things that they're watching may change. Initially, people watched a lot of news, right? And then doctors started advising, please less on news, more on comedy shows, right? So naturally, your algorithm, which was predicting which show you would like to watch, has to change now. So then you basically go through the whole cycle again, maybe retrain your model and so on, and you do your concept drift related testing. Any questions, guys, here? I know this is a very heavy diagram, a lot of things happening, a lot of different types of tests. And I have not included some other tests like back-to-back tests and so on. But this should give you a good enough idea. I'm sure you are aware of adversarial robustness, ICANN, and GANs. So I'll give you an example of GAN. Maybe that would be interesting for you. Okay. Just give me a second. Where is my... Yes. By the way, were you able to see my presentation, or I had not shared it?
You said your screen is not visible.
Now it is not, but when I showed the diagram, was it visible?
Yes, sir.
All right. So just give me a second. I will show something to you. After that, I'll resume my presentation. Okay. So just a second, please. Okay, I'll share my screen now. For some reason, the system has become slow. Okay. So I guess you can see this, right? Which face is real? Now they are generating using GANs, generative adversarial networks. They are generating faces of people, and to me, both look just the same. Meaning both look real to me. Well, I can choose one which is not real, and I choose that, the second face is not real on the right hand side. I choose that, and let us say what it says. Incorrect. The image on the left side is the real one. This is not the real one, but it looks realistic. Let's play it again. I'll do it just once more. and I say, who is real? Maybe this person, again, right-hand side person is real. You're correct. But the second, on the left-hand side also looks realistic enough. There are more GANs available, which can actually, which produce even better results. This is just an example. So for test data generation, such GANs are being used more and more. Okay. Coming back to our presentation, I hope you can see my same diagram again. Now, let us do some testing. We have how much time? 20 minutes. So let's do some testing. The top picture and the bottom picture, both are pictures of wolves. Okay. My image recognition algorithm or classification algorithm actually classified the top wolf as a wolf and the bottom one as a husky. Any idea why this might have happened? A husky looks very similar to wolf, by the way. And the interesting thing that people found out in this case was that when they trained the system, all the wolf images they had given had snow in the background, and all the huskies images they had green, tree forest kind of a background. So anytime, so the machine actually didn't learn to distinguish between a wolf and a husky. What it learned to distinguish was white color and green color. So all white colored things became wolves, and all green background became husky. It didn't even look at the features of a wolf or a husky. Now it was, as long as your test data had wolves in white and huskies in green background, your model was working accurately, 100%, and you were very happy. Right result arrived at using wrong method. Now, how do you test for it? How do you know how to test for it? That is one of the biggest challenges. In this case, of course, background is something very easy to, if you do a visual inspection of all the data, background is something very easy to recognize, but may not be. I'll give you another example. They automated opening gates of a metro station so that if there's a lot of crowd, lot more gates are in service. If there's less crowd, less number of gates are in service, and so on. And they took crowded platforms videos, fed it to their system, and it started working very well. Every day it was working flawlessly. And then on one of the days, so weekend, no crowd, nothing. Weekdays, crowding hours, it worked really well. And then one day, despite the fact that there is nobody on the platform, very little number of people, a large number of gates were open. They couldn't understand why. And then they did investigation and they found out that actually in all those images that they had fed or all the video, there was a clock that was there which showed, and they were feeding in the date and time. And it looked at the date and the time, and it found out every day from 8 a.m. to excuse me, 8 a.m. to 10 a.m. when the clock face was like this. There's a lot of crowd, so I should open. Not a lot of crowd. Clock is like this, so I should open the gate. Clock is not like this, I should not open the gate. On a bank holiday, there was no crowd, but it was a Monday, and the clock was between 8 a.m. to 10 a.m. It opened the gates. Now, such subtle things, how do you know? And that is where explainability then comes into picture. Okay, so we'll talk about explainability if you want me to, but explainability is trying to find what exactly. So you ask the system, why did you take the decision that you took? And the systems maybe highlights this particular feature caused me to take this decision. Now you look at the feature, you look at the clock and say, oh my God, it's looking at the wrong thing. And then you can feed more data, which doesn't include clock and so on, and you remove the problem. So that is how explainability helps. Now there's this Uber accident that happened. What was happening was this, self-driving car killed a woman. let's not get into the details of what exactly happened. You can later on maybe look at it. But the thing is, the car's radar and lidar, they actually detected that there is something there. First, she was detected as an unknown object, then as a vehicle, then as a bicycle, and every time, because there was path adjustment that was happening, the car was also moving, so path was being adjusted all the time. But by the time it recognized that there's a bicycle and a human, and there's going to be a collision, only a few hundreds of milliseconds or maybe a second left, and the car brakes didn't happen, and the woman died. Okay, what went wrong? Why was emergency braking something that didn't happen? Well, first of all, just let's look at how many scenarios you will need to test. For example, it's possible that there was not much light, so it was very dark. So the camera wasn't really working all that well. Lidar was, radar maybe was, but that's about it. So that means you need video feeds of cars moving around traffic where it is very dark. Well, maybe darkness was not a problem. The road was well lit, but the woman came from darkness into light suddenly. Or maybe a woman came from light into darkness suddenly. Now you need to basically test for those, right? Maybe it was a foggy day. So do I have test video clips of foggy days of the same scenarios? Lidar has a problem. If something is perpendicular to it, the identification is not that good. Maybe that was the problem. Maybe women had been trained, all lighting conditions had been used, but a woman with a bicycle was never crossing the road, was never fed into the system to train. Or maybe women with the bicycle was fed, but just somebody who's pulling along a bicycle but not riding it was not done. Or maybe the bicycle had a lot of different objects. It was totally covered with hay or something else, and so it was not recognized as a bicycle. Maybe it was recognized as a shadow. Maybe the women's clothes had a lot of green or flowers and all, so it thought maybe it's just part of the road. There are flowers there. So you have to look at all of these scenarios. Maybe the woman was actually moving erratically, not moving, and so on. Or there were sudden movements. Or there was exhaust fumes which caused destruction. Infinite scenarios can be there. Can you even think of all these scenarios? This is one of the challenges. And then how are you going to get this? So are you going to basically drive all the time on the road, and you'll have people to ask them cross the road wearing different clothes, different cycles, different prints, and so on? No, it's going to be a problem. Why it happened was a separate thing. The thing is, first of all, to test it, not only I need object recognition, I also need path determination, which is a separate algorithm. Then I also need a decision being taken. What is the best approach? Should I swerve? Should I hit? Should I apply brakes? And so on. So that decision needs to be taken. And all of this has to happen in real time. So is my model doing all of this fast enough? So performance becomes important, and so on. Actually, the emergency brakes could have been applied. There were two types of emergency brakes: the autonomous systems and the cars, because you should not have two masters. There should be only one master. So they disabled the emergency braking of the car, and emergency braking of the autonomous system didn't work, and there was a human being who could have actually averted the disaster in the car, but she was busy playing on her mobile and so on. So, problem. So if you want to really understand how the technique linguistic analysis can be used, there is this YouTube video link. You can actually, there is a better link which I can probably provide you right now. It's very easy for you to remember after that. bit.ly/LA method. Okay, you can use this. I will just reshare my screen because it is possible the sharing has come. Or yeah. So it's a 2-hour presentation that I have on linguistic analysis method and how it can be used to generate good number of test cases. I'll give you an example of how this method can be used. This is a visualization of object identification using your phone. A person is sitting on a chair, the phone is on a table, maybe with a stand or in person's hand, doesn't matter. There's a light, there's a fan, there are walls, table. Now, there are so many variations we can bring into this. For example, lighting condition. The lamp could be of various types. It could be incandescent bulb, it could be tube light, LED, right? The fan could be stationary or moving, resulting in a flickering effect of light and so on. The walls could be dark or bright, and that may have an impact. The table surface may be polished or matte finish, or could be transparent and so on. Could have a lot of different patterns on it, matching the object or not matching the object and so on. Object could be placed at different places in the view area of the camera and so on and so forth. So just take a look at if I'm doing this. So there are camera characteristics. If I'm doing a book scan, there are light source characteristics. There's a background, there's a book, the content, the color of the pages, right? And how the text has been laid out, whether it has text only, images, combination, blank page, the curvature of the book, right? How much of the book is covered, not covered. There may be shadows, there may be creases, crinkles, torn paper, correct? There may be some spots. Maybe you were eating while you were reading the book, and so there are stains and so on. Now, you may need to get all of them to basically do good testing. So in this case, what I did was I started writing all these different variations that are possible. For example, for an object, there can be different shapes, sizes, colors, surface, type of object. Surface has reflectivity, transparency, smoothness, color, pattern, material. Light sources could be artificial, natural, systems, and so on. Now, all of these combinations, if you do, you cannot do all the combinations. So you can try to do pairwise testing. For example, background light sources with object background light sources, and you can say these kind of combinations I'm interested in. Then there are some data augmentation related or metamorphic testing related transformations you could do. For example, you could do shear, you could do rotation, you could translate the object to the left, to the right, top, bottom, etc. You could zoom in, and that also is a very interesting thing. You could so there are RGB, for example, if you are dealing with RGB, these 3 channels, and then you could change the intensity of those. You could do blurring. So many different things that are possible with respect to the images also. Again, you can choose your combinations here. So then for a vision-based ML pipeline, you could choose different background, different lighting, different positions of object, and different image transformations, and then go for more combinations and combinatorial testing. Our product AI Ensured, that's the name of our product. Test AI testing with instead of I you having AI. So our product is able to do data augmentation and generation, fairness evaluation, corner case generation using metamorphic testing, also coverage based testing for the neurons. We have multiple explainability methods and explainability score. We have a good security adversarial robustness testing tool. We can integrate with AutoML, lot of ML workflow tools. Linguistic analysis is something that research is going on, and we'd be happy to have bright students working on LA as a research project. There are a lot of patents we are going to file on LA and so on, and we file patents for research that we do. Then we have tests for privacy and GDPR compliance as well. We have tests for performance optimization, etc. So this is what our product can do. There's no other product that we are aware of which can do all this. Most of the products that we are aware of usually deals with metamorphic test. With explainability and almost that's about it. So with that, I finish my presentation so that we can have a few question answers if required. I hope I'm in time.
Yes, sir. Yes, sir.
All right. Questions, any? So the only concluding remark I can give from this perspective is that it's a very exciting field. Not too many people are working on it. There's a lot of research potential of doing things and interacting with the industry to do things.
Yes.
Uh, there are people who are working on it, but please understand that bias is a very human thing, right? And it is very hard for a machine to be able to say whether there is bias or not. You can only look at statistical characteristics or have a catalog of biases and say this is how these biases are, in which case AI would be able to do things. One of the research that we are doing, so for example, videos, uh, the biggest problem is understanding of the context. Segmentation, etc., can happen very easily, but it is the context determination which is the problem, and a lot of people are working on that. But to use that for bias, I think we are still a little far from that in terms of definition. I'm sure some research would be happening. You can connect with me offline, and I'd be happy to um, uh, share more information if I get.
Sir, can we have a sir's email ID or mobile number so we can get in touch with them?
Let me put it here. Okay,
Yeah.
just a second. So beneath this, I am putting my email ID. Okay, you can see my email ID now.
Yeah.
All right. Perfect then. Thank you. Namaskar. Sure. Understood. Sure.